Okay, question 7 in our inequalities of chapter 2 gives us an inequality that we probably, or an equation that probably appeared in equation form in chapter 8, but this time it's in chapter 9 as an inequality. But we're going to solve the same way we would have if it was an equation from chapter 8. And the first thing we're going to do is we're going to multiply both sides by 10. And that's going to create this inequality, keep it still unequal, but yet balanced on both sides. So if I have half, a negative half of x multiplied by 10, I'm going to do this first one using distributive property. I'm going to cross multiply, and I'm going to get negative 5 over 1. I'm going to keep my negative in the numerator to make it easier. And I'm going to end up with a negative 5x as my first term. If I have 10 of those negative half x's, I actually end up with negative 5x. And then when I multiply the next one by 10, negative 3/5 multiplied by 10 over 1, cross multiply, I get take away 6. And I'm going to keep my symbol the same. It's going to be greater than or equal to, cross multiply, 9. It's the exact same value, just 10 times greater on both sides, and now there's no fractions. Now the next thing I'm going to do is I'm going to add 6 to both sides. I get the negative 5x is greater than or equal to 15. And the last thing I'm going to do is I'm going to divide both sides by a negative 5 coefficient to get x. Now here's where it gets tricky. Now I'm going to put a little note over here. Note, if you get rid of a negative coefficient, whether it be in fractions or whether it be a multiplier coefficient, that's either multiplying or dividing, I'll put that in brackets, by a negative number, you must, I'm going to put this one in big letters, flip your sign, your inequality sign. Inequality, I'll just put the sign. So because I divided here, both sides by negative 5, I'm going to keep, I now have x, but I'm going to flip my sign from this way to this way here. I didn't do that very good. But because it was greater than, it's now going to be less than or equal to negative 3. Okay? Negative 3. Now, if you don't believe me, let's go back up and check that out. So I'm going to put, because this equal sign is here, I'm going to go up and put that negative 3 symbol in here. So if I was to substitute negative 3 for the x, I would have, let's just rewrite it again. X over negative 2 take away 3/5 is greater than or equal to 9/10. I'm going to rewrite that one here as being negative 3 over negative 2. Take away 3/5 has to be greater than or equal to that. Well, let's just check this out here. Let's just erase all this stuff and see if that's true. So this is really 1.5. Take away 3/5 is going to be greater than or equal to 9/10. Right? That's what that means. So we're going to put a positive 3/2. Take away 3/5. I'm just, I don't know why I did that. I'm redundant, but that's okay. I'm going to find my common denominator just to check it out. I'll use not 5, but 10. 10 and 10. So 6/5 and 15. Take away 6 is going to be greater than or equal to 9/10. And when we actually subtract those two, we actually see that 9/10 is going to be greater than or equal to 9/10. And remember, my value was that all numbers less than or equal to negative 3 will work. So if I chose another number that was less than negative 3, for example, if I chose negative 4, let's just choose negative 4 and see if that works, because that's less than it. Negative 4 halves, negative halves, that's, we're going to use our common denominator of 10 again. So we'll just make sure those are positives, because we know negative divided by a negative. We're going to have 20/10 take away 6/10 is going to be greater than or equal to 9/10. Let's check and see if that makes sense. That's going to be 14/10 is greater than or equal to 9/10. And indeed it is true. So as we continually make this number here less than negative 3, we're going to see this inequality still hold true, that this side is going to be greater than this side, if we think about it that way.